In the last class we covered why this is happening. Okay, in the last class we covered differences among AI, ML and DL. After that we learned what is machine learning, difference between traditional and all, why we use machine learning examples and the applications, generalized applications of this. Okay, in the last class we started the topic type of machine learning, right? So as we discussed, there are three major types of machine learning: supervised, unsupervised and reinforcement learning, right? We already discussed it in the last class. So in the first part, as we already discussed, that supervised machine learning needs labeled data, right? In the GIF, in the presentation, you can see we are giving the training data on which we are giving them the images and corresponding output. Let in this case we are giving the images of banana and saying that this is banana, output as a this is banana. And after learning, whenever we give new input of any banana shape, it will simply predict that this is banana. So what it means that in supervised learning, the machine learning model will learn on the basis of input given and output corresponding to those input. So it will match those input output patterns and find some relation or find some patterns out of those data, and then only it will infer some basic relationship between the images, different images given, or different data inputs given with respect to their output, right? Once it learned and once it trained successfully on the training data, it will simply whenever in the future we show machine learning model the shape of banana, it will identify it as banana with some accuracy parameter, right? Let's say it is a this machine learning model will give
सर वॉइस ब्रेक हो
no issue guys,
सर वॉइस ब्रेक हो रहे हैं.
wait for a minute, maybe there is a network issue. Let's check, am I audible now guys?
Yes, sir.
Okay, okay. There may be some network issue due to the rain also. So do tell me if you are not listening my voice right correctly, right? So in the first type of machine learning type, unsupervised supervised machine learning, simply we gave the we train our machine learning model on input and their corresponding output. And machine learning model, at the time of training, machine learning model try to find some relationship between those input and their corresponding output, and make some rules that if this input is given, that means this will be the output, right? In the same way, when it is got trained, and when we gave some unseen data like new shape of banana or new image of banana to the learned model, it will simply identify those inputs to correct output. Like in case we are giving it shape of banana, it is showing that this is banana, but this is it will not say it will not tell you the correct uh, exact it will not tell you the exactly, it will tell you the probability of being banana, not the correct answer. It will give you the probability of being banana, means it will say that there is a chance of 92% that this shape, given shape is belongs to banana category, right? So this is how our supervised machine learning works, right? So come to the next type, we have unsupervised learning. As we discussed, it is used to work upon unlabeled data. We are not going to provide any label to the given input data, and machine learning algorithm automatically learn from the data and cluster them out, right, into different categories. So in the next image you can see how machine learning algorithms works. We throw some raw data to our clustering algorithm or unsupervised machine learning algorithm, and according to their some similarity rules, it will cluster them out into multiple groups, right? You can see in the image that it is simply doing, it is separating clusters on the basis of some similarities, right? Some similarity rules. So this is how unsupervised machine learning works. I think this is clear to you. Now come to the next third category, which is reinforcement learning, right? So as we say that, as we said that machine reinforcement learning is totally based on how human learns from the environment. So we simply put our algorithm into the real world scenario or real world task in our environment, and the algorithm will learn automatically by that environment on the reward and punishment basis, right? So in the next image you can check. See, in this image you can see that the algorithm is trying to learn to play Mario game, and it whenever it moves correctly, correct movement, it is taking correct movement, it is rewarded. See the right hand side window, receive direct reward and discount expected future rewards. So if sometimes it, in the meanwhile, if it is got killed or vanished by opponent, it will punish it as a reiterating pattern, right? It will say, algorithm will say that play it again, because you took wrong decision, you need to play it again, so that next time when you play, you won't take this type of mistakes, right? So this is totally reward and punishment based algorithm, where algorithm will be rewarded with for correct movement and will be punished for wrong movement, right? So this is how reinforcement learning works. Here we are not providing any data to the our algorithm. We are simply putting our learning algorithm to the environment directly. Like in case of this example, we are putting our algorithm to direct game, right? By using emulators, right? We have some emulators on which emulators are the softwares or mix of software and hardware which act on the behalf of human beings, right? It will take actions according to defined rule, right? So if so this is all about reinforcement learning. Now sometimes sometimes we have the situations that we don't have labeled data, correct labeled data, in and we have to classify those data into different classes, right? In that case, what we can do, we can mix supervised and unsupervised algorithm together. Let's see how. Firstly, we simply put those unlabeled data to our
ने
unsupervised.
एक
बच्चे माइक बंद करो, किसका माइक ओपन है? ठीक है. So in the fourth category, which is hybrid one, which is a semi supervised learning, where it is simply, I told you that it is used in the case when you have we have unlabeled data and we need to do some classification task on prediction tasks on that. But for those tasks we need labeled data, but we don't have right now. So for that, what we will do, we will put those data into the unsupervised learning algorithm, clustering algorithm, which will cluster them out into different groups, and we will give them those classes or those clusters a proper name, proper label. After labeling the all the data, we can provide these data to the supervised learning algorithm, which further will used to train our model, and after training the model, it in the future unseen data, it will directly classify or predict the output correctly on the basis of our labeled data, right? So what's written over there, see, semi-supervised machine learning algorithm falls somewhere in between supervised and unsupervised. That means it is a mix of supervised and unsupervised learning algorithm. Since they both labeled and unlabeled data for training, typically a small amount of labeled data and large amount of unlabeled data. See, why we use unsupervised machine learning here? Because we don't have complete data labeled. So we want those data to be labeled. That's why we use clustering algorithm in that case, right? Okay, the system that use this method are able to considerably improve learning accuracy. Okay, usually semi-supervised learning is chosen when acquired labeled data require skilled and relevant resources in order to train it and learn from it. Otherwise, acquiring unlabeled data generally doesn't require additional resources. Okay, so that means if, let's say for example, I downloaded some chest x-rays from the internet, and I don't know that what this x-ray means. It is whether it is belongs to pneumonia, whether it is this x-ray belongs to chest x-ray belongs to covid and all. But I want them to identify that this is I want them to be labeled according to their defined rules, right? So we what we will do, we will use clustering algorithm will separate them out in two groups. Some images falls under group 1, and some images falls under group 2, covid group, right? Then what I will do is I simply check group 1 images, and by with the help of radiologist or available label data, small amount of available label data, I will give that cluster a name. For example, let's say first group I found with the help of radiologist information that these images are related to pneumonia cases, and second group belongs to covid cases, right? Then I simply label those clusters with proper names. After labeling proper labeling, then we can use supervised learning on those data, right? I think you understood this point, right? Where we use hybrid type of learning. Got my point, guys? Okay, now this is all about types of different types of available machine learning algorithms we have in the market, right? And generally in general, most of the time we are using supervised learning algorithm for different classification or regression task, right? And nowadays we in the medical field, especially in the medical field, we are using hybrid learning, semi supervised learning, because every time we don't have labeled data, medical data, right? Labeled medical data, so we need to label them correctly before using it to train any model, right? Now now come to the machine learning process. See, machine learning is not about classifying or predicting something. It is a pure hybrid science where you need knowledge of different domain. Let's say if I am working in medical domain and I am using machine learning in medical, that means I need to have knowledge of machine learning as well as the knowledge of that particular field. That means that particular medical field. If I am trying to I am trying to build a model for cancer classification, that means I need to be aware of cancer related information, that how why cancer how cancer looks like in the images, and like that, you know. So the machine learning process consists of these different steps. Firstly, you need to understand the domain, or we can say prior knowledge and goals, what you are going to do. If you are let's say in the my example, if I am going to build a classification model on lung cancer, that means I need to know I need to know prior knowledge of our lung cancer domain, and what I am going to do. Let's say I am going to classify lung cancer images into non-cancerous and cancerous domain. That means I need to know that lung cancer image looks like this, non-lung cancer image looks like this, right? So before going to the machine learning process, you need to understand what you are for what you are developing model, for which domain you are doing this machine learning process, right? So first step is knowing your domain where you are going to put your machine learning upon, right? Now next step will be data integration, selection, cleaning, and pre-processing. This is the major step. This is the uh, main focused area in the machine learning. See, next step will be you need to collect the data, right? You need to integrate the data collected from different sources, right? Then you need to collect proper data, like in for example, if I am doing I am what I would say, I am building a model for lung cancer. That means I need to collect images. Let's say I am working on medical data, medical imaging. Then that means I need to collect all the images of the lung cancer or cancer related images. After that, I will select the best possible images which are accurate enough to be defined as lung cancer, right? And along with some non-cancerous images also, right? Because data is main important part here. After selection, I need to clean our data. I need to remove noises, like let's say if I am having image of lung cancer, definitely there will be some other organs will be there also in the MRI scan or CT scan. So I need to remove those information before putting them to the model. So that is called pre-processing, right? In the pre-processing step, we are doing data wrangling, data cleaning, data selection part, right? After when once we clean the data, see, this step is important here, because our machine learning model will learn from data, and if you are providing some wrong data or misinterpreted data to the model, it will definitely give you the wrong result in future after training. So remember always that if you are going to use any machine learning algorithm, check your data before inputting to your model, because if you provide it clean data, it will give you a correct result with higher efficiency. But if you are providing raw data or mixed data or incorrect data, definitely it will the learned model will misclassify your output, right? So this is the major important part. So this comes under the feature engineering part. The data provided to the machine learning is called features in the machine learning language, right? After that, when you cleaned and pre-processed your data correctly, then only you provide those data and corresponding output to your model, right? Let's say you are designing SVM model or random forest model, like that. There are multiple models, numerous models available in this library, right? So once you clean the data, you put those data to your machine learning algorithm, and machine learning algorithm will train upon it train itself upon it, and find some relation between input and output, given input and output, and learn some patterns from those data. After that, once you trained your model, you test your model on some small amount of data. You provide some unseen data, which were not used in at the time of training. You provide it to the machine learning learned machine learning or trained machine learning model, and it will generate output corresponding to given input. And you need to check that the output given by the model is correct or not, because you have some ideal value for ideal output value for the given input, and you are getting some input from some output from your model. Now you need to compare these two, the output given by your model and the real output, what it should be, right? Then you will compare and check how much the error is there. If the error is very high, that means your model is not trained perfectly, your model is not generalized perfectly. That means this is the overfitting overfitting problem. We will discuss it into later what is overfitting. That means overfitting means the in the training time the model perform very well with the accuracy of 95%, but at the time of testing the accuracy is somewhere around 60%, 70%. So that means what it means that the data you provided to the machine learning algorithm is not that much accurate, which which establish a correct relation between input and output and provide you a correct output. So if your model is providing higher accuracy in the testing part, in the testing interpretation domain, that means your model is good enough. But if it is not the case, that means your model is overfitting, your model is not properly generalized, your model is not properly learned. You have provided some wrong data to the your model at the time of training. So next step will be interpret result. What we are discussing right now, that falls under interpret results. After after interpreting your results, if you find that your error rate is less than 2%, less than 1%, that means your model is trained in very well manner, right? That means you can use that model to predict something or to classify something. After that you can deploy it to the real time scenario, right? But this is not the case. This is not that simple as we imagine. It is very tough, because sometimes what we are getting higher accuracy at the time of training and lower accuracy at the time testing. If we are getting lower accuracy at the time of testing, that means your model is not perfect and you cannot deploy it into the real world scenario. So these five processes, the five steps will be reiterated again and again until and unless you are not getting sufficient accuracy on the given task, or that particular goal which you want to achieve, right? So this is the basic five steps of machine learning process. Now come to the next what we have. See, now you can check in the image. Is images visible? Images visible, guys?
Yes, sir.
Okay.
Yes, sir.
So you check what we have
Yes,
discussed.
sir.
Okay. So you can check in the image. This is the basic flow chart of supervised learning. See what we have discussed right now before this machine learning, in the machine learning process. These all are the steps involved on that, right? See, first step will be collect raw data. Okay, then after pre-processing, we pre-process the data. After that we simply split those data into two parts. One is training data and testing data. First part will be training data, and second portion will be as a testing data, on which we will test our learned model, right? And training data will be used to train our model. After classifying our splitting our training our data sampling uh, as training data, we will pre-process again our training data, like which all are the features we have to select, which features need scaling. See, you we are dealing with the machine learning, and machine learning works on computers, and computers cannot cannot perform well if you are giving them multiple distinct value. So you need to scale your feature values into the range of 0 and 1, 0 to 1. You need to scale your features, so this is called feature scaling. Now after that, dimensionality reduction. Sometimes we have thousands of features in the input data, and out of 1000, let's say only 300s are the are features are the correlated to the are correlated highly correlated to your output value, then you need to select only those 300 features. That is comes under dimensionality reduction. What it means, simply you are reducing your dimensionality, because if you are providing higher number of features to the learning model, it it will be get complexed, right? So you need to give them only those features which are highly correlated to your output. Not all features are required, right? Okay. Next, after pre-processing, we provide this pre-processed data to our machine learning algorithm, and we start machine learning training part, right? After that, once we train the model and we found that the efficiency is somewhere around 80%, but we need more than 95% or 90%, that means we need to do some optimization part. So that's why parametric optimization comes into play, right? In this case, we will optimize our parameter machine learning algorithm parameters on different bases, and after optimizing, then only we can post process our model. That means we can check our model on the performance metrics like accuracy part. There are different KPIs, performance metrics available, on which any ML algorithm will be benchmarked, right? So after performing training part, when you checked the after parametric optimization, if you are not getting proper performance metric, that means you need to use another model. You can have multiple multiple ML model to train, right? So you will train one by one all the models and check the efficiency. If you are getting best efficiency in one type of machine learning model, you will use that particular model only. Not all the models are required, right? If you are not getting proper accuracy, that means you need to change your model accordingly, so that you will get perfect output as a classifier, right? Once you chosen your ML algorithm and checked your efficiency on training data, you need to evaluate your machine learning on testing data, which we already split it at the time of beginning, right? At that time we will check that whether this model is performing well also on testing data. If it is the case, then that means you can use it, right? But if it is not the case, you need to check that what are the data you have provided, how your learning took place, whether this model is perfect or not, and all that on the basis of performance metrics. If you are finding that your accuracy is better, testing accuracy is more than 95%, which is required by you, then only you can use new data. See, in this in this part, there is new data. Once you find your model is perfect one, it is not overfitting, then you can use that particular model, learned model, to predict something or to classify something, right? On the basis of new data. Now you will provide new data, real time data, unseen data to the algorithm, and that algorithm will classify or predict some values on the behalf of you for those given input, right guys? So this is the basic this diagram consists of all the major steps involved in the supervised learning, right? Supervised machine learning. So this is all for the day, guys. I think you understood it, and you understood the different steps involved in the machine learning process, and this is all we need to understand in throughout our subject. In this subject you will understand these all steps in the future coming lectures, right guys? Thank you.